Chapter 9.1 Solving Systems Using Substitution. We can encounter problems with solving systems by graphing. Solutions can be inaccurate, it can be hard to deal with fractions, a large number of solutions come up with decimal answers, and we may not have access to a graphing calculator. We need to be able to solve systems algebraically. One algebraic method is the substitution method. For the substitution method, first number your equations before you start. So equation number 1 and equation number 2. Step 1, isolate one of the variables in either equation. It doesn't matter which variable you isolate or which equation you use. So usually you just look to see if one is easier to isolate and you do that one. In our equations, 3x plus y equals 3 and 7x minus 2y equals 20. The y in the equation 1 looks easier to isolate, so that's what I'm going to do. Step 1. Isolate y in equation 1 because it looks easier. Looks like the easiest variable to isolate in these two equations. So it doesn't actually matter which one you isolate. Sometimes none of them are any easier, so you just pick one, isolate it. So we have 3x plus y equals 3. We want to isolate the y, so we're moving 3x to the other side by subtracting 3x. Then we get y equals negative 3x plus 3. We can call this equation number 3. It's just a modification of equation number 1. Step 2, substitute the isolated variable into the other equation and solve. So step 2, the other equation, so the one that we didn't isolate, that is equation number 2. So we're going to sub negative 3x plus 3 into equation number 2 for the y value. Because we said y equals negative 3x plus 3, so if we have a y value in equation 2, we can replace that y value with negative 3x plus 3, since they're the same thing. So then we have 7x minus 2y equals 20. Replace the y with negative 3x plus 3, we get 7x minus 2 times negative 3x plus 3 equals 20. In step 2, we're also solving for our variable. So notice that when we replace the y with 3x plus y, now equation 2 only has x's. If we only have one variable, we can now solve for that variable. So that's the whole point of doing the substitution, so that we end up with only one variable, and then we can solve. So sub negative 3x plus 3 into 2 for y, then solve for x in this case. So we want to multiply negative 2 into the brackets. We get 7x. Negative 2 times negative 3 is positive 6x. Negative 2 times positive 3 is negative 6 equals 20. 7x plus 6x is 13x minus 6 equals 20. I want to isolate the x, so add 6 to both sides. 13x equals 26. Now we have 13 times x. We want to divide by 13. That gives us x equals 2. So that provides us with the x value of our solution. Next, we need to determine the y value, which is step number 3. Use your answer to solve for the other variable. So we now have that x equals 2. We can sub that into any of our equations, 1 or 2 or even equation 3. And what you'll notice is that equation 3 has the y value isolated. Step 3, sub 2 into 1 or 2 or 3 for x and solve for y. So any of those three equations, the easiest ones are 1 or 3. There's just less calculations to do. For 3, the y is already isolated, so that would be the easiest. So if I did that one, y equals negative 3x plus 3. Replace x with 2. Negative 3 times 2 plus 3. Negative 3 times 2 is negative 6 plus 3. Y equals negative 6 plus 3 is negative 3. So that's the y value of our solution. Then step 4, write down the ordered pair that satisfies both equations. And we can do a check to verify our answer. So step 4 is the solution, which in this case, x is 2, y is negative 3. So that ordered pair is our solution. And just to be sure, we can do a check. Remember, I need to check the solution in both equations of the system. So our solution is 2, negative 3. Let's check that in number 1 first. 3x plus y equals 3. 3 times 2 minus 3 equals 3. 3 times 2 is 6. 6 minus 3 on the left, 3 on the right. 6 minus 3 is 3 equals 3. That's true. So the solution works for equation number 1. Then equation 2, 7x minus 2y, right side is 20. 7 times 2 minus 2 times negative 3, right side is 20. 7 times 2 is 14. Negative 2 times negative 3 is positive 6, right side is 20. 14 plus 6 is 20, the right side is 20. So the solution works in that equation as well. So it is a solution to our system. Example 3x plus 2y equals 19 and 2x minus 3y equals negative 9. We're going to start by numbering our equations 1 and 2. Then we want to isolate one variable in one equation. In these equations, there's not really any variable that looks easiest to isolate, so just pick one and go with it. I'm going to isolate y in the first equation for no particular reason. So step 1, (3x plus 2y equals 19). Subtract 3x from both sides. We get 2y equals negative 3x plus 19. Divide by 2 for all the terms. Y equals negative 3 over 2x plus 19 over 2. We can call this equation number 3. Step 2 was to sub the information from equation number 3 into the equation we haven't used yet. So sub negative 3 over 2x plus 19 over 2 into equation number 2, because I haven't used that one yet, for y. Since y was the variable that was isolated in equation number 3, then we get 2x minus 3y equals negative 9. we're going to replace the y in this equation with negative 3 over 2x plus 19 over 2 equals negative 9. We need to multiply the 3 into the brackets. Then it becomes 2x. We're going to use our calculator to multiply these fractions. We have negative 3 times the fraction, negative 3 over 2 is 9 over 2, so plus 9 over 2x. If you can't enter fractions in your calculator, just do negative 3 times. You can put brackets around the fraction part, negative 3 divide 2, close bracket, and then enter, and then change it to a fraction, 9 over 2. Then the next one, negative 3 times 19 over 2, negative 3 times math fraction, 19 over 2 gives us negative 57 over 2, so minus 57 over 2 equals negative 9. We want to combine like terms. We have 2x and 9 over 2x. We can just use our calculator. 2 plus fraction 9 over 2, and we get 13 over 2 minus 57 over 2 equals negative 9. If you can't enter fractions on your calculator, do 2 plus bracket 9 divide 2, and then change it to a fraction, 13 over 2. So now we want to isolate the x. We want to add 57 over 2 to both sides. Then we get 13 over 2x equals negative 9 plus fraction 57 over 2, which gives us 39 over 2. Or can't enter fractions, negative 9 plus bracket 57 divide 2, 19.5, change that to a fraction, we get 39 over 2. And then we have 13 over 2 times x, so we want to divide by that whole fraction. Divide by 13 over 2, divide by 13 over 2. 13 over 2 divides out on the left, we get x equals 39 over 2 divided by 13 over 2. We can just use our calculator. So math fraction 39 over 2, move out of the fraction, divide fraction again, 13 over 2. So 39 over 2 divided by 13 over 2 gives us 3. And again, if you can't enter fractions, just bracket 39 divide 2, close bracket, divide bracket, 13 divide 2, close bracket, and we get 3. So x is 3. That's half of our solution. We now need to find the y value of our solution. So step 3 is to sub x equals 3 into one of our equations to solve for y. Which equation looks easiest? 1, 2, or we can use 3. 3, we've already isolated the y, which is what we're trying to solve for, so that would be the easiest one. So sub 3 in 4x in equation 3 and solve for y. Y equals negative 3 over 2 x plus 19 over 2. Sub in 3 for x, we get y equals negative 3 over 2 times 3 plus 19 over 2. And then calculate. fraction, negative 3 over 2, move out of the fraction, times 3 is negative 9 over 2, plus 19 over 2. We have common denominators, so we can add those fractions by adding the numerators. Negative 9 plus 19 is 10 over 2. If you want to just use your calculator, that's fine. Math, fraction, negative 9 over 2, move out of the fraction, plus second fraction, 19 over 2, gives us 5. So 10 divided by 2, simplified, gives us y equals 5. So we got an x value of 3 and a y value of 5. And then step 4 is to put those together to write the solution. The solution is the coordinate point 3, 5. And then it doesn't say that we have to verify, but we can verify our answer as an extra step here. So we need to make sure that our solution works in both of the equations, starting with equation 1, 3x plus 2y equals 19. Our solution is 3, 5, so sub in 3 for x, 3 times 3 plus sub in 5 for y, so 2 times 5 equals 19. Calculate the left side. 3 times 3 is 9. 2 times 5 is 10. The right side is 19. 9 plus 10 is 19, which equals 19. So it works in equation number 1. Let's check that it works in equation number 2, which is 2x minus 3y equals negative 9. X is 3, so 2 times 3 minus 3 times 5, y is 5, equals negative 9. 2 times 3 is 6. 3 times 5 is 15, so 6 minus 15 equals negative 9. 6 minus 15 is negative 9, which equals negative 9. So it works in both equations, which verifies that it's a solution to the system. Word problems. Megan has $9.65 in her wallet. She only has nickels and quarters. If she has 41 coins in total, how many of each coin does she have? So we need to define our variables. We want to know how many of each coin does she have. So those would be our variables. N equals number of nickels, and Q equals number of quarters. Then we need to write two equations to model the situation. Equation number 1, we have 41 coins in total. That tells us that N, the number of nickels, plus Q, the number of quarters, equals 41 coins. Equation 2, we know the value of the coins in total, $9.65. So we can write an equation to represent that. The value of a nickel is 5 cents, which as a dollar is written 0.05, times the number of nickels, plus the value of a quarter is 0.25, times the number of quarters, equals the total value of all the coins, $9.65. Now we can start to solve. Step 1, we want to isolate one of our variables in one of our equations. Equation number 1 definitely looks easier. I could isolate either variable. I'm going to isolate Q. So we have n plus q equals 41. Subtract n, then I get q equals 41 minus n, or negative n plus 41, doesn't matter. I'm going to call that equation number 3. Then step 2, we want to sub in 41 minus n for q in the equation we haven't used yet, which is equation number 2. 0.05 n plus 0.25 q equals 9.65. Now I'm going to replace q with 41 minus n. Then I get 0.05 n plus 0.25 times 41 minus n equals 9.65. Then I need to multiply the 0.25 into the brackets, and we get 0.05 n plus, need our calculator, .25 times 41 is 10.25, and then 0.25 times negative n is negative 0.25 n equals 9.65. Combine our like terms, which are the n values, 0.05 n and negative 0.25 n. 0.05 minus 0.25 is negative 0.2, so negative 0.2 n plus 10.25 equals 9.65. We want to isolate n, so subtract 10.25 on both sides. 9.65 minus 10.25 is negative 0.6. These two add to 0, so we get negative 0.2 n equals negative 0.6. We have negative 0.2 times n, so we want to divide by negative 0.2 on both sides. Negative 0.2 divides out on the left. We get n equals negative 0.6 divided by negative 0.2 gives us 3. Step 3, we want to solve for q. We can plug n equals 3 into any of our equations, 1, 2, or 3, to solve for q. In equation number 3, q is already isolated, so I'm going to plug it into that one. Q equals 41 minus n. Replace n with 3, 41 minus 3, so q equals 38. Then step 4 is to write our solution. For word problems, we don't usually write an ordered pair, so we don't even know which variable goes first or second, since it could be either. But if you were asked to write an ordered pair, you could write it either as 338 or 38.3. They would both be correct. But for word problems, we just typically write a statement. So we can write Megan has 3 nickels and 38 quarters. And again, just to double check, we can verify our solution. Equation number 1, n plus q equals 41. 3 plus 38. 41 on the right. 3 plus 38 is 41, which equals 41. So we know the solution works for equation number 1. Then equation number 2, 0.05n plus 0.25q equals 9.65. That becomes 0.05 times 3 plus 0.25 times 38 equals 9.65. And then we're going to need our calculators. $0.05 times 3 would give us 15 cents. 0.15 plus 0.25 times 38 is 9.5 equals 9.65. 0.15 plus 9.5 gives us 9.65. So 9.65 equals 9.65. So we verified our solution for both equations, which means we have verified that it's a solution to the system. At a dance recital, there were 220 people. Tickets cost $9 for an adult and $6 for a child. The dance school collected $1,614 in ticket sales. How many adults and how many children attended the recital? We need to define our variables first. The question being asked tells us what our variables should be, how many adults and how many children attended the recital. So A equals number of adults and C equals number of children. We need to write two equations to represent the situation. We know that 220 people attended. So that means the number of adults, A, plus the number of children, C, equals 220. That's equation number 1. Equation number 2, the other information we have is the cost. For adults is 9, for children is 6, and the total amount of ticket sales was 1,614. So then we have 9 times A plus 6 times C equals 1,614. Then we can start to solve. Step 1, we want to isolate one variable in one equation. Equation 1 looks easier to deal with. Isolate one of those variables. I'm going to isolate C, so I have A plus C equals 220. Subtract A, I get C equals 220 minus A, or negative A plus 220. Step 2. Now that we have C isolated, which we can call equation number 3, we're going to sub the information in to equation number 2 for the C value. 9A plus 6C equals 1614. Replace C with 220 minus A. 9A plus 6 times 220 minus A equals 1614. Multiply the 6 into the brackets. 9A plus, we need 6 times 220. 6 times 220 is 1320. So 9A plus 1320. 6 times negative A is negative 6A, and then equals 1614. Combine our like terms. We have 9A and negative 6A. 9 minus 6 is 3A plus 1320 equals 1614. And then isolate A. Subtract 1320 from both sides. Those add to 0, we get 3a equals 1614 minus 1320 is 294. Divide both sides by 3. 3 divided by 3 is 1, so we're left with a equals 294 divided by 3 is 98. So a equals 98 means there's 98 adults. Now we need to figure out how many children attended. That's step 3. We know that a is 98. We want to solve for c. I can use equation number 3. C equals 220 minus a. Sub in 98 for a. Use my calculator. 220 minus 98 is 122. And then step 4, $122 children and 98 adults attended the recital. And since I have the space, I might as well verify. Equation number 1, a plus c equals 220. A is 98. C is 122. Use our calculators and check if that equals 220. 98 plus 122 is 220. So 220 equals 220. Second equation, 9a plus 6c equals 1614. 9 times 98 plus 6 times 122 equals 1614. 9 times 98 is 882. Plus 6 times 122 is 732 equals 1614. Add those together. 882 plus 732 is 1614. So 1614 equals 1614. We verified the solution for both equations, so we verified it for the system. Last one. This is a very challenging question. So we have a boat traveled 325 kilometers downstream. The trip took 5 hours. The return trip took 13 hours. Find the speed of the boat in still water and the speed of the water current. So we need to define our variables. The question tells us what we're looking for. Find the speed of the boat in still water and the speed of the water current. So we can say that B equals speed of boat in still water and C equals speed of current. The information we're given, a boat traveled 325 kilometers downstream. So that's a distance. The trip took 5 hours, which is a time. The return trip took 13 hours, which is also a time. And we want to find the speed. So we have distance, time, and we're looking for speed. If you have taken Science 10, you might remember this. If you haven't taken Science 10, we have the formula D equals S times T, which is distance equals speed times time. We're going to make a table of values. We're going to have 2 rows and 3 columns. So our 3 columns are going to be distance, which is in kilometers for this question, speed, which would be in kilometers per hour for this question, and time, which is in hours. And then we have 2 rows, which represent going downstream, and then the return trip, which means we're going upstream. So the distance in kilometers, it says a boat traveled 325 kilometers downstream. The trip took 5 hours. The return trip, so that means they came back, which means they would have to also go 325 kilometers. So our distance is 325 kilometers for both downstream and upstream. We'll jump to the time. We're told that the trip going downstream takes 5 hours, and the return trip, so going upstream, takes 13 hours. Now we need to think about the speed. When you're going downstream, you have the speed that your boat would be going in still water, but you're also being pushed by the current. So your speed is being increased by whatever the speed of the current is. So the speed when we're going downstream would be B, the speed of the boat in still water, plus C, the speed of the current. When we go upstream, we're going against the current. So the current is pushing against us, which means we're going speed B, the speed of the boat in still water, minus C, the speed of the current. Then from our table, we can get our 2 equations because we have the formula distance equals speed times time. So equation number 1 is for going downstream. We have 325 equals B plus C times 5. And equation number 2, 325 equals B minus C times 13. I'll write those again over here. 1 is 325 equals B plus C times 5, and equation 2, 325 equals B minus C times 13. Step 1, isolate one of your variables in one of your equations. They both look equally as difficult to isolate. I'm going to do number 1, and I'll isolate B. So 325 equals B plus C in brackets times 5. I want to isolate the B, so I'm going to start by dividing both sides by 5. $325 divided by 5 gives me 65 equals B plus C. Then subtract C, and we get 65 minus C equals B. That can be equation number 3. Step 2, now that we've isolated one variable in one equation, we want to sub the information back into our other equation. So we did not use equation number 2, we're going to use that one. 325 equals bracket B minus C, close bracket, times 13. We're going to sub in 65 minus C for the B value. 325 equals bracket. B is now being replaced by 65 minus C, and then we have minus C again. Close bracket times 13. Simplify the brackets. 325 equals 65 minus C is minus 2C times 13. Then multiply the 13 into the brackets. 325 equals 65 times 13 is 845. Minus 13 times 2 is 26C. And then we want to isolate C, so minus 845 from both sides. 325 minus 845 is negative 520 equals negative 26C. Divide both sides by negative 26. Negative 520 divided by negative 26 is 20 equals C. Next we need to solve for B. We have that C is 20. We can plug that into any of our equations, 1, 2, or 3 to solve for B. Equation 3 is already isolated for B, so that would be the easiest. We'd have B equals 65 minus C. B equals 65 minus 20. So B equals 45. And step 4. Write the solution. It's a word problem, so write a statement. C represents the speed of the current and B the speed of the boat in still water. The speed of the current is 20 kilometers per hour. And the speed of the boat in still water is 45 kilometers per hour. So that type of word problem, in my opinion, is the most challenging type you'll see in this unit, but you're going to use distance equals speed times time. You're going to make a table. Once you've made your table, that gives you your two equations, and then you solve from there. It's coming up with the equations that's the hardest part, but if you use a table with distance equals speed times time, you should be able to get there. That brings us to the end of Chapter 9, Lesson 1.